Hello, good day. I am Noel, your learning buddy in this video, and I'll be teaching you how to create a formative assessment using GeoGebra with instant feedback like this. So basically, we have here the slope and have the students to move these 2 points around so that they grab the line with the specified slope. Now in this case, we have the slope -8 all over 3. Now, if the graph is correct, it will automatically give an instant feedback. Now to test, we have -8 for the rise, 1, 2, 3, 4, 5, 6, 7, 8. And for the rise, we have, for the run is 3, 1, 2, 3. Now, the graph is correct, so it gives an automatic or an instant feedback. So we'll create this kind of activity right now. So open your GeoGebra app and let's do this activity. So I am now in the GeoGebra app and I am using a GeoGebra Classic 5, and it may be different from yours, but the features are just the same. Now by default, you can see here grid line with axis, the X and Y axis. Now we don't want this anymore. So to remove this, just right click on the grid and then uncheck the axis. Now the next step is to fix the scale of the grid lines. Now to make this, right click on the grid and then on the graphics and the X axis, we have to put check on the distance and put 1. Same also on the Y axis, put check on the distance and input 1. And on the grid, we're going to choose major grid lines on the grid type. I'm going to exit. Now, when we speak about slope, it is a rational number, so we need numerator and denominator as it is in rise over run. Now in the input, we're going to encode n list. Okay, we'll have to list the possible numbers for the numerator. So to do this, encode n list equals then sequence. Okay, then choose the last one, and then in the expression just put I, variable I. In the start value, you can start any value you want, but this moment we'll have -10 and the end value is 10 and the increment is 1. Now as you notice here, it will automatically create a sequence from -10 to +10. Now that is for the numerator. Now in the denominator, we must remove 0 because it will make the slope undefined. Now to do this, we have to encode denominator left, or let's d left equals sequence again, the last one, then the expression I, variable I, and the start value, since it is left, we're going to make use of -10 and the end value must be -1 and the increment is 1. Now for the right, we have d right. D stands for denominator equals, we're going to create again a sequence, the last, and then the expression I, variable I. Now the start value, we're going to start at 1 and the end value must be 10 and the increment is 1. Now as you notice here, the denominator will now have no 0. Now we're going to make a denominator list. We're just going to make a union of the left and the right. Now to do this, we're going to input the list. So we are now making a list for the denominator equals, and then union list. So we're going to choose this, and then for the list we have d left, okay, d left and d right. And this is now our list for the denominator. Now, conventionally speaking, our slope is denoted by m. So we're going to input m here equals, and then we want GeoGebra to randomly select any number in the numerator list and in the denominator list. Now to do this, we're going to input random element. Okay, so first we have the n list, then the numerator, and then divided by, because this is a ratio, divided by, again, random element, and at this moment we're going to choose d list. Now as you notice here, it will automatically create a number which is actually the slope. Now in order to fix this as a fraction, then we have to input fraction text number and then put m here on the number. As you notice here, it will create number here, same with our slope, and this is actually what we want our students to see later on. So going to unhide it first, and then on the caption encode new problem, and then in the GeoGebra script encode update construction with big letter U and big letter C, and then open and close bracket. Okay, so I'll just make it wider. So notice here it will create new problem here, and it will you can move freely. Now to fix this, okay, right click, then you just have to check all these three. Okay, next, so that it will not be moved anymore. Now the next step is to make a direction, so using text, and then create your direction. So for the meantime, our direction is move the large points around so that the line displayed has the given slope. Okay, then click OK. So you can also fix this, or you can move this to here. Okay, and then right click to lock and to finish screen. Okay. The next step is to we want the students to see the given slope, so we need to make another text, and then choose the latex formula, and then italize, and then encode slope equals, and then under the icon for the GeoGebra, okay, then we're going to choose text 1 because this is what we want our students to see. Okay, so we have now the slope, so you can also move this. Okay, then fix this here, slope. Going to right click, lock, and then pin. The next step is to put a line, so click here and then line, and then we have to select 2 points, so here and here, so any point. Now we can you can actually move these points, but we want this point exactly on the grid. Okay, now to make that, so just click here on the grid and then just the magnet here, set point, capture style, and then fix to grid. So notice, okay, it will now automatically be fixed on the grid. Now we don't want to see the label of the points, so to remove this label, right click on this point and then uncheck the show label, the same with this point. Now we want the students to see a larger point. Now in order to make this larger, just go here and then adjust this to your desired number. So let's just make it 8. Same also with this, going to make it 8 points. Now let's measure the slope of this line. So in order to do that, go to this button and then choose slope, and then you have to click the line. Yes, you notice here, as I move the points, the slope also changes. Let us now create a feedback, a correct feedback. So to do that, click on text and then encode whatever feedback you want to give to your students. So we'll have "you're correct." And then okay, now you can change the font style or the font size here by just clicking this. So right click and then setting, and then on the text you can actually set it into large. Okay, and at the color you can also, for the foreground, background, and for the background let's choose this, and for the foreground let's have this. Okay, then exit and then fix to where you want it to be displayed. So let's just put it here and then lock it, then pin it to the screen. Now we want this feedback to appear only when students graph it correctly. Okay, when I move this, okay, it will disappear, but it's not the graph of the given slope. But when I click the new problem here, it is still here. Now to do it, right click the setting and then on the advanced, okay, condition to show object. So our condition is this feedback will appear when our m sub 1 and the slope, okay, when the slope m sub 1 and the slope are equal. So to do that, just input m sub 1 equals m, then we have to press enter. As you notice here, it disappears. Okay, now in order to check whether it appears when our graph is correct, okay, so we'll just have to move these 2 points. So the rise is negative 7, so 1, 2, 3, 4, 5, 6, 7, and our run is 4, so 1, 2, 3, 4. So it appears when our graph is correct. Now we don't want our students to see this, so we just have to right click and then unclick the show objects. Okay, then have to move this one. Then for the new problem, we have negative 7. Okay, negative 7, that's 1, 2, 3, 4, 5, 6, 7, and then the run is 1. So that's correct. For the new problem, negative 9, 8, 9, and then 5 for the run, 1, 2, 3, 4, 5. Hi. So that is one of our activities in GeoGebra. I hope you learn on how to make this activity. God bless.